In this particular problem, we're going to take signs times signs, numbers times numbers, variables of the same power times variables of the same power. Now, what I'm going to put up here now is what I consider a think step. Okay, I'm going to put a think step, but think step. And then I'll show you what I would probably actually just write down if it were me doing. Here for the R's, I'm going to think R to the third plus fourth. Okay. And then for the S's, I'm going to think S to the first plus fourth. So what I ultimately would write would be 32 R to the seventh, S to the fifth. Now, do I need to require you to show that step? No. Okay, now we're using the distributive property. By the way, what we're going to be doing about half of the class today, actually we have already done. But it's just review before we go into some other stuff. And review and extension, maybe a little harder powers. So we're going to take this times this times this, and this times that. 5 times 2 is 10. Okay. And y cubed times y second is y to the fifth. Term. Here, -7 times 5 is 35, -35, and y fourth. Again, I'm doing 3 plus 1. Plus 5 times 6 is 30, and just bring over the y cubed. Done. Again, we've done kind of this stuff, just not with so many variables at the same time is the only real difference. They're going to show you basically the same thing I showed you. Now we just get a little nastier numbers still. Okay, we're going to distribute. -4 times 2 is -8. A to the third times a to the first is a to the fourth. B to the seventh times b to the second is b to the ninth. C to the first times c to the fourth is c to the fifth. And likewise over on the other side. Okay. Now, here's as far as I took it. This side over here, -4 times -1/2 is +2. A to the third times a to the fifth is a to the eighth. B to the seventh times b to the first is b to the eighth. And the c tags along. Do you need to show this? Not on a problem like that one. I mean, it's relatively simple. Okay, if you want to show some of this stuff, you can, but you can see how I went straight from this to that. Well, here are a couple more. I can go through these, or we can go over these, or past these. Your call. Anyone want to see either one of these? What? Okay. Now we're moving into multiplying polynomials. In this case, we have a binomial times a trinomial. Okay. Conveniently, they have the binomial in front. If they did not, I would suggest that you do, Because why do you want to be distributing 3 things when you only have to distribute 2 things? Okay. So here's ultimately what they're going to do. Now they're going to show you some steps in here, but fundamentally, we're going to take 2x squared here, which is going to give me 6x fourth. Okay, and this one, we're going to have 2x squared minus x. So we're going to have minus 2x cubed. Here, we're going to have x squared. Now we'll do this one. 4 times 3x squared is 12x squared. And I'm going to line these up. Okay. 4 times x is negative 4x. And 4 times 5 is 20. And now I'm going to simplify it. And that's how I would do this particular problem. They're fundamentally doing the same steps. Here I took the 2x squared times the 3x squared. They're just showing that you're gonna do it right here. This is a gonna do step, if there's such a term. And here are the do steps. See there. Oh, I got careless. Okay, and then we just combine the like terms to get the ultimate same answer. Anyone need to see this one or wish to see this one? No? Same process as last time. Okay. Now we've got binomial times binomial. Okay, we've done this before. Here's the gonna do step. We're gonna multiply 3y times 7y. We're gonna multiply 3y times negative 6. We're gonna multiply 2 times 7y. We're gonna multiply 2 times negative 6. And here's where they actually do it and then combine like terms. We can combine this 18y and this 14y, so the thing simplifies to that for the final answer.